Hello all, welcome to my YouTube channel. Today we shall study scatter plot and correlation. We can see relationship everywhere. For example, relationship between height and weight. As height increases, weight also increases. We can see relationship between age and height. As a baby grows, with his age, his height also increases, his weight also increases. Okay, so these examples I have cited, or in these we can see that as one variable increases, other variable is also increasing. So there is a direct or positive relationship between two variables. There are examples where we can see the inverse, that is when one variable increases, the other variable decreases. For example, as the speed of car decreases, the time to reach the destination increases. Okay, so this kind of relationship is called negative correlation. Okay, so this correlation between two variables can be plotted in a graph which is called scatter plot. Let us see this example. Height and weight of 4 individuals are given. For height is in centimeter and weight in kg. Okay, so we shall plot a scatter plot to see the relationship between height and weight. Suppose this is the graph where we shall plot the points. Okay, so what we do in x-axis, we write down the heights, and in y-axis we plot the weight. Okay, now for first sample, point 152 height, weight is 48. So from here x-axis we find out the point 152, and from y-axis we find out the point 48. Okay, so put a point here, dot here. Then next sample point is 155 and 50. So in the x-axis we find out the point 155, and in y-axis we find the point 50. Okay, so this will be our second sample point. Okay, for the third sample and the fourth sample we draw similar dots. Okay, for the third sample, for 157 the weight is 54, it comes here, and for the fourth one, for height 160, the weight is 55, so 160, 55 somewhere here. Okay, so these dots are known as scatter plot. Okay, so what is the importance of this scatter plot? We can see that as height increases, that is we are going to the right side of the x-axis, okay, the weight also increases. See, the dots are showing a positive trend, increasing trend. So we can see that height and weight are positively correlated. Now I shall show you how to draw scatter plot in Excel. Okay, so we put the data points in Excel, height and weight. There are two columns, and along the first column height we write down all the 4 heights, and along the second column weight we write down all the weights. Now after we put down the data, we select the entire data, and then we go to insert tab, and from insert tab we choose the scatter plot. Okay, scatter plot looks like this. Okay, so this is our scatter plot. Now along the x-axis we shall write down our height, and along the y-axis we shall write down weight. Okay, so we go to chart design, and then we go to add chart element, which will be extreme left side. Okay, so then we choose axis titles, and axis titles we choose first primary horizontal. Okay, and here we write down this X is title height. Okay, and then we go to chart design again, add chart elements, and from X is title we choose the primary vertical, and then along this vertical axis we write down weight. Okay, we can change the title of the graph. Okay, we can write it as height versus weight, weight versus height. Okay, now scatter plot doesn't only say that whether there is positive correlation or negative correlation, it also says the degree of relationship. Okay, see the first chart, scatter plot 1. Okay, here we can see that all the dots are plotted along a straight line. Okay, which means there is perfect positive correlation between two variables X and Y. Okay, now come to chart number 2. Here we can see that though they are showing a positive trend, but they are not along one straight line. Okay, they are closer to a line. So there is positive correlation, but it is not perfect positive correlation, but high correlation between two variables X and Y. See the third plot. We cannot understand any trend from this third plot. Okay, all the points are scattered randomly, so there is zero correlation between the two variables X and Y. Now see the first scatter plot. Okay, we can see that as X increases, Y is decreasing. Okay, as we going to the right side of X axis, in Y axis it is going down. Okay, so this is called perfectly negative correlation. Okay, since all the dots are along a straight line, so this is perfectly negative correlation. See the second scatter plot. We can understand a trend which is negative, that is as X increasing, Y is decreasing, but points are not along a straight line, so we can say that there is a negative correlation, but comparatively strong negative correlation. See the third scatter plot. Here we can understand that as X is increasing, Y is decreasing, but points are very much away from a straight line, so there is a weak negative relationship between the two variables X and Y. Okay, now correlation coefficient is given by R, lowercase r, and it lies between -1 to +1. If r equal to -1, there is perfect negative relationship. Okay, and if r equal to +1, there is perfect positive relationship between two variables. Okay, and if r equal to 0, there is no linear relationship between two variables. Okay, now the formula for correlation coefficient, Pearson correlation coefficient, is given by r equal to covariance of xy divided by square root of variance of x and square root of variance of y. Now if we are given x, y, and then we can find out the variance of x and variance of y and covariance of x, y, and now then put the values to get correlation coefficient. There is another formula for correlation coefficient which is given by r equal to n into summation xy minus summation x into summation y divided by square root of n summation x square minus summation x whole thing square multiplied by square root of n summation y square minus summation y whole thing square. We shall use this formula to find out the correlation coefficient. Suppose this example, height and weight, we find out the correlationship between height and weight. Suppose height in given by x and weight is given by y. Okay, then we shall need x square, another column, y square, and then a third column xy. So we need to construct this. So x square will be 152 square, okay, y square will be 48 square, and xy means 152 multiplied by 48. Similarly, we do the calculation for other rows. Okay, I am showing my calculation here. So this we got x square the third column, y square the fourth column, and xy the fifth column. Then we find out the sum of all these. Okay, sum of each column. After adding each column, we get summation x as 624, summation y as 207, summation x square 97378, summation y square 10745, and summation xy 32324. Okay, now we shall put these values in our correlation coefficient formula. Putting these values in the formula for R, n is 4. There are 4 data points given, so n equal to 4. So 4 multiplied by summation xy, that is 32324, minus summation x into summation y, that is 624 multiplied by 207, divided by square root of n summation x square, that is 4 into 97378, minus summation x whole thing square, that is 624 square, multiplied by square root of n into summation y square, that is 4 into 10745, minus 207 whole thing square, that is summation y whole thing square. Okay, putting these values, we find the correlation coefficient to be 0.95897 or approximately 0.96. Rounding to 2 decimal places, we find out the correlation coefficient to be 0.96. So this is very much close to +1. So we can say that there is a strong positive correlation between height and weight. This is the chart for degree of correlation. Okay, so here in the left side of the table we have absolute value of correlation. That means if correlation lies between 0 to positive 20 or positive 0.20 or negative 0.20 to 0, there is extremely weak correlation. 0.20 to 40 is weak correlation, or negative 0.40 to negative 0.20 is weak correlation. 0.40 to 0.60 moderate correlation, 0.60 to 0.80 strong correlation, and 0.80 to 1 is extremely strong correlation between two variables. Now we shall discuss correlation and causation. If two variables x and y are correlated, that means one affects the other. For example, height and weight. As height increases, it increases the weight as well. Okay, so one affects the other, but this is not always true. Correlation does not always mean causation. Two variables may be highly correlated, but there may not be a cause and effect relationship between them. Let me give you an example. There has been found a high correlation between sales of ice cream and death by drowning. Okay, but in reality, if you can see that sales of ice cream and death by drowning, there cannot be a cause and effect relationship between these two. Then why this high correlation? Okay, so this high correlation happens for the effect of confounding variable. Okay, what is that confounding variable? That is summertime rise in temperature. Okay, so as temperature increases, sales of ice cream increases, and as temperature increases, more people go for swimming, and there accidents happen during swimming and people die. So the confounding factor temperature is the cause here for these two sales of ice cream and death by drowning both increases, and we can find a high correlation between them. though there is no causation. Okay, hope you understand whatever I try to teach you in this video. Hope you like my channel. If you like my channel, please like and subscribe for more such videos. Thank you for watching.